Hey everyone, and welcome back to Analyze with Casey, where we dig into the real world messiness of artificial intelligence, AI, and healthcare. If you caught episode 1, we unpacked the basics: what AI is, how it's trained, and how it's already being used in radiology. But knowing what AI is doesn't mean you understand how it functions in the real world. Today, we're going deeper. We're not talking theory, we're talking workflow, the chaos, the shortcuts, the human friction. Because the truth is, AI doesn't operate in a vacuum. It enters a system filled with existing protocols, burnout staff, and unpredictable data. So let's crack open that black box and walk through what happens when AI meets the radiology pipeline. Let's start at the beginning of a typical AI-assisted imaging workflow. A scan's taken. This could be a CT, computed tomography, MRI, magnetic resonance imaging, or chest x-ray. It gets pushed into PACS, the picture archiving and communication system, which stores and organizes medical images. AI kicks in. An AI model, such as those developed by companies like Aidoc, immediately scans the image for key conditions like pulmonary embolism, brain hemorrhage, or pneumothorax, which is a collapsed lung. If a serious issue is detected, the system can move that scan to the top of the radiologist's reading list for urgent review. The flagged case may come with a marked up image, a confidence score, or a suggested diagnosis. Ideally, this helps the radiologist decide faster. On paper, this sounds fantastic, but in practice, radiologists are managing a high volume of cases. If AI flags too many things or doesn't clearly explain why a scan is high priority, it can get ignored. So the big question is AI helping us find the needle in the haystack, or is it just tossing in more hay? There's a fine line between AI being a helpful assistant and AI being that coworker who interrupts you every 5 minutes to tell you something you already know. Picture this. You're reviewing a stack of CT scans. You're laser focused, you're coffee fueled, your headphones are in, you're in the zone. Then boom, a pop-up. Possible PE detection. That's a pulmonary embolism, by the way, a potentially life-threatening blood clot in the lungs. Pretty serious stuff. But here's the thing. Maybe you already saw it, or maybe the AI flagged something that isn't even there, wasting your time and attention. This is where trust becomes everything in the human-AI partnership. If the AI frequently makes mistakes, trust drops. If it's vague, something like possible abnormality detected with no location, no probability score, no real explanation, it slows you down. If it flags everything, even the minor stuff, that's called alert fatigue. And it's very real. Think of it like the boy who cried out wolf, except this time it's the algorithm, who cried urgent over and over until you just stopped listening. But here's the flip side. When the AI does catch something subtle, maybe a tiny lung nodule or early signs of a brain bleed that the radiologist might have missed due to time pressure or fatigue, that moment is golden. That's the moment where AI becomes a safety net, a second set of eyes, a real partner. But here's the truth. AI has to earn its place in the room. Radiologists aren't asking for a robot overlord or a magic crystal ball. They want tools that are clear, reliable, and integrated in a way that supports, not distracts. So yes, AI has potential, but if it's not implemented thoughtfully, it can easily cross that line from being helpful to just another thing radiologists have to work around. Here's where it gets messy, because implementing AI in radiology isn't just a tech problem, it's a people problem. Radiologists are human. Shocking, I know. But it means they each have their own way of working. Some prefer to dictate their findings using voice recognition tools. Others rely on highly structured templates that match their cognitive flow. They've developed these habits over years, sometimes decades. So when you drop an AI tool into that workflow, even with the best intentions, friction happens. Say your software takes an extra click, or it puts the AI report in a separate tab, or it forces them to reformat their entire workflow just to see your output. That's enough to cause eye rolls, resistance, and even total abandonment of the tool. Not because the tech is bad, but because it doesn't fit the real world they work in. And let's not forget the technologists, the techs who actually operate the scanners. These folks are the front line of image acquisition. They know when a patient is wincing in pain. They know when a scan looks off before anyone else. So if the AI flags something concerning, who's responsible for saying something? Should the tech alert the radiologist immediately? Should they wait? What happens when the AI is wrong? Right now, in many settings, there's no clear protocol, no standard operating procedure, just a lot of uncertainty. And that opens the door to another silent threat: automation complacency. This happens when people start trusting the AI too much. They stop questioning it, stop verifying, and that's when mistakes slip through the cracks. It's the same pattern we've seen in other industries. Aviation, for example, where over reliance on autopilot has led to devastating consequences. In healthcare, that risk is even higher because lives are on the line. This is why how we roll out AI tools matters just as much as what those tools do. It's not just about installing a flashy piece of software or celebrating a high accuracy score. It's about changing how people work, how teams communicate, and how trust is built or lost. And if you're watching this as a data analyst, listen up. Your model doesn't exist in a sterile lab. It's stepping into a messy, high pressure, emotionally charged environment. Your job doesn't end at the F1 score. Your model's performance depends on human behavior, institutional culture, feedback loops, and yes, your ability to explain your model's outputs in plain language. In other words, even the best algorithm in the world is only as useful as the workflow it respects and the people it supports. If you're a data analyst or a machine learning fan watching this, you might be thinking, okay, Casey, cool story about radiology, but what does any of this have to do with me? The short answer: everything. Because building a model in Jupyter Notebook or KNIME is one thing. Getting that model to work in a hospital full of burnout staff, outdated hardware, and 20 open browser tabs is something else entirely. Let's break it down. In testing, your model might be 95% accurate. You might even have a sweet looking ROC curve and a polished PowerPoint to back it up. But in the real world, the CT scanner might be 15 years old and produce lower resolution images than your training set. The radiologist might skip the AI suggestion entirely because it's buried 3 clicks deep. The EMR, the electronic medical record system, might not even display your model's output in a way that's readable or trusted. Here's where it gets real. Deployment isn't just a technical process, it's an integration problem. That means you're dealing with humans, systems, habits, and culture. And if you're not accounting for that, your model doesn't stand a chance. Let's talk about feedback loops. In the clinical setting, are radiologists allowed to connect the AI? Are those corrections logged and used to retrain the model? Who owns the data? And how often is your model being updated? Because if you're not learning from the real world use, you're not doing machine learning, you're doing a demo. You also have to think about equity. And I don't mean just checking a box. Ask yourself, was the training data collected from diverse populations? Does your model perform equally well on scans from different hospitals, different imaging devices, different patient demographics? Or did it accidentally learn to favor one group? Maybe because that group had more consistent data or higher access to care. If your AI model works great on 60-year-old white men, but struggles with Black women or patient in rural hospitals, you've got a bias problem, not just a performance issue. These are the invisible landmines that turn promising models into paperweights. And this is why understanding the healthcare workflow is so critical, even if your title says data scientist and not clinician. Now, in episode 3, we're going to get hands on. We'll be jumping into KNIME, which is the Constance Information Miner. It's a free visual drag and drop data science platform. No coding required. We'll walk through importing healthcare data, cleaning it up, building a simple classification model, and mapping the kind of workflow that could, if deployed properly, support real decision making. Because here's the truth: flashy tech doesn't save lives. Well integrated, equitable, human centered systems do. And that's what we're building here. So make sure you're subscribed, because episode 3 is going to show you how to bring the AI hype down to earth and make it work where it actually matters, in the clinic. Good AI isn't just accurate, it's usable. That means it doesn't just spit out a diagnosis and walk away. It fits into the way real people actually work. It respects the workflow. It supports radiologists and technologists, and it doesn't try to replace them. Because if your model only works in a lab but fails in a live hospital, it's not a solution. It's a science fair project. And that's where our next episode comes in. We're going to stop talking about AI and actually build something. We'll dive into KNIME, a visual data science platform. No code, no expensive software, just a smart, accessible way to take raw data and turn it into an AI model you can see, understand, and improve. We'll walk through cleaning a messy medical data set, building the model logic, connecting each part of the workflow like digital Lego bricks, whether you're a radiologist curious about how AI works behind the scenes, or a data analyst ready to build models with real impact. This is where the worlds collide. So here's what I want you to do. If you like this video, if you learned something today, subscribe if you want to keep learning. Comment below, has AI ever helped or hurt your workflow in healthcare, in data science, or anywhere else? Your experience might teach the next person something powerful. I'm Casey, and this is Analyze with Casey. Let's keep asking better questions, building smarter systems, and making tech that works for people, not just around them. I'll see you in episode 3.